Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullah Kareem. This problem is related to partial differentiation of differential calculus. If z is equal to x plus y multiplied by phi, which is function of y upon x, then prove that x del 2z over del x square minus del 2z over del y del x is equal to y del 2z over del y square minus del 2z over del x del y. We are given that value of z, which is function of x and y, x plus y multiplied by phi y upon x. I give it is equation number 1. To prove this equation, we have to find the value of del 2z over del x square, del 2z over del y del x, which is equal to del 2z over del x del y. So we will find this value only. It is not always equal, but for continuous function these value are equal. So we will find only this value. If you want to find this value, you can do as it, which will be equal. So I find this value, and this value, and means all these value. What we have to find first derivative, because these are second derivative with respect to x, xy, y with respect to y. What we have to first differentiate z with respect to x, means first derivative of z with respect to x. So differentiating equation 1 partially with respect to x, we get del z over del x. On differentiation of this quantity, differentiation of x with respect to x is equal to 1, and differentiation of y with respect to x 0, because for partial differentiation y is constant for x. Now we have to differentiate this quantity, which is a function of multiplication of two function. I consider it as a first function and it as a second function, and apply product rule. So first function as it, differentiation of second function, which is function function phi, which is function of y upon x. So it will differentiate only with respect to y upon x. So I differentiate it phi with respect to y upon x. So we get phi dash y upon x. What we are differentiating it with respect to x. So differentiation of this become this, what it is not x. So we have to differentiate y upon x with respect to x according to chain rule. First function as it, differentiation of second, what it is not x. So we have to differentiate this value. What here we are seeing that y is constant, so I take it here, and only we have to differentiate 1 upon x. Differentiation, we know that differentiation of 1 upon x equal to minus 1 upon x square, as you know. Now we apply we are applying product rule, and first function as it, differentiation of second function, and second function as it, differentiation of first function. Differentiation of x with respect to x is 1, and differentiation of y with respect to x is 0. Now we can write it as write 1 here, and we have minus y upon x square. This value is minus y upon x square. I multiply this value to in this bracket, so we will get minus y upon x square. Multiply here, x cancel out x square, so we get y upon x, and also we get this term also becomes minus according to this minus. We get y into y square, and here x is in denominator, x square is in denominator, and which is multiplied by y dash y upon x. I multiplied this whole value to this bracket and get this value. Now I write this term 1 multiplied to this function equal to 5 y upon x. This is value of del z over del x. We should make it as equation 2. We will use this equation to further differentiation, because we have to find the second derivative of z with respect to x square. So we have to differentiate this value with respect to x again. So I write here differentiating equation 2 partially with respect to x. We get on differentiation of del z over del x square, we get del 2 z over del x square, which will be used in proof of given equation. Differentiate on right hand side. Differentiation of 1 is equal to 0, which is constant, and when we will differentiate this value, first we differentiate this term with respect to x. Minus y is constant. Differentiation of 1 upon x equal to minus 1 upon x square. So this sign convert to plus, because minus multiplied by minus plus and upon x square. Also differentiation of this, we get minus y square as constant taken out, and differentiate 1 upon x square. When we take it to a numerator, then degree of x become x to the power minus 2, and differentiation of x over minus 2 is equal to minus 2, which convert this minus 2 plus minus 2, and x to the power minus 2 minus 1, which convert becomes x to the power minus 3. If we want to change it in positive power, so we take it to in denominator, so power of x becomes x to the power plus 3. This is differentiation of this value with respect to x, and we consider this is the first function and it is second function. First function, differentiation of first function, and write difference second function as it without any change, plus differentiation first function as it, right, first function as it, minus y upon x minus y square upon x square, and differentiation of second function. Differentiation of y dash equal to y double dash. It is differentiation with respect to y upon x, but it is not x. So according to chain rule, we have to differentiate this value. When we are going to differentiate y upon x, here y is constant, we have to only differentiate 1 upon x. We know differentiation of 1 upon x equal to minus 1 upon x square. I write this is as. So we go to next term, because I have completed this product of first differentiation of first, second as it, differentiation of second, first as it. Now differentiate this term, differentiation of this, becomes this y dash. We write it as y dash, which is differentiation of phi with respect to y upon x. What we are differentiating it with respect to x, so differentiate this value. So differentiation of y upon x is equal to with respect to x, for x y is constant, so y take y constant as, and differentiation of 1 upon x is equal to minus 1 upon x square, and I convert this bracket into curly bracket. And next term we calculate some value. First of all, I want to collect the coefficient of y dash y upon x, which is present here and here. So I write this term. This term is y upon x square, and next term plus 2 times y square upon x cube, and I write this term on taking this common, minus y upon x square, minus y upon x square. This is coefficient of y dash upon y upon x, on taking common y dash y upon x out here, and coefficient becomes this. And now we have to write only this term. This term is on multiplying minus y upon x square. In this term becomes as I write here, minus this minus convert to plus y into y becomes y square, and x into x square becomes x cube. So I write here x cube. When this value multiplied to this, then this sign convert to plus, because it is minus sign, and y square multiplied to this y become y cube, and x square multiplied to x square become x to the power 4, and I write this value y double dash y upon x. We are seeing here y upon x square, which is y upon x here, which is negative, and this term is positive, so this value is cancel out. Here minus y upon x square I multiply in these two terms, then these terms become this, because this have had hidden, so I tell you, I write this here, and this value cancel out. I write in next page del 2z over del x square, which will use in next del 2 z over del x square, and this only this term, and means coefficient of y dash upon equal to 2y square upon x cube. I write 2y square upon x cube phi dash y upon x. And now I will write the next term as it without any change. I write it this I will this value in upcoming steps or phases. I write this as equation 3, because we have two equation other than this. Now we have to find the second derivative of z with respect to yx. So we must differentiate equation 2, because in equation 2 we have del z over del x. when we differentiate it partially with respect to z, we will get del 2 z over del y del x, which will become which will equal to this, because here z is a continuous function, which is not necessary to show this is a continuous on this level, means BSc level, graduation level. These values are always equal, so you can use it, or you can if you want to find out this, you can also find as according to this value. So I differentiate equation 2, so I write here differentiating equation 2 with respect to y, we get equation number 2. On differentiation, we get on left hand side del 2z over del y del x, because here del z over del x present, and now differentiating with respect to y, we get d2 z over del y del x. On differentiating equation 2 with respect to y, on right hand side, we can differentiation of 1 is 0, so I write 0 here, and after it here we are saying that there are two terms, two functions, we consider it two function, so apply product law here. First I differentiate this value and remain this value as it, so I differentiate first function, first function, because it is consist of two terms. First term differentiate with respect to y, so minus 1 upon x is a constant, so I write minus 1 upon x. Differentiation of y with respect to y equal to 1, and next term we are consider minus 1 upon x square is constant, so I write minus 1 upon x square is constant, and differentiate y square, which is equal to 2y, and write second function as it y upon x. So I applying here product rule, differentiation of first second function as it. Now I write second function as it, and second function as it, and differentiation of first, so I write it is as second function as it plus write second function as it minus y upon x minus y square upon x square, you can see in equation number 2, and differentiate second function, which is differentiation. On differentiating this, because this is by dash first derivative, on differentiation with respect to y, it becomes y double dash, but it is also function of y upon x. What here we are seeing that it is not y, so I differentiate y upon x with respect to y. For y, x is constant, so take 1 upon x as constant, so I take 1 upon x as constant, and differentiation y with respect to y, we get only 1 upon x, you can only write 1 upon x. Now third term we have to differentiate, and differentiation of this term it becomes y by dash y upon x, but it is also not y, it is function of y upon x. So by chain rule we must differentiate it as previously 1 upon x as a constant, so I take 1 upon x as a constant, and differentiation of y with respect to y is equal to 1. Now I calculate, I collect coefficient of y dash y upon x, phi dash y upon x, sorry. So we get first term minus 1 upon x here, and after it I write this value 2y upon x square, and now this value which is equal to 1 upon x, which is coefficient of y dash y upon x. So I write these terms. Remaining terms are these, so I write this term, and I can take minus from this bracket, so this sign becomes minus, and this both term becomes positive y square upon x square. First term is y upon x, and this y double dash y upon x multiplied by 1 upon x. 1 upon x cancel out by minus 1 upon x, because it is value positive, this is negative. So I write next term which is minus 2y upon x square y dash y upon x. We can also multiply 1 upon x to this term, then this term become x multiplied to x, it becomes y upon x square, also y square upon x cube, which is coefficient of y double dash y upon x, and this is value of del 2 z over del y del x. It is not value of not only value of del 2 z over del y del x, it is also value of del 2 z over del x del y. You can solve it, or you can use as I use it. So I write it as equation 4, and I will use in successive steps. So we go to next step for finding the other values, because we have find these values only, we have to find this value. So first for this value we should differentiate z with respect to y for first derivative of z with respect to x. So I write differentiating equation 1 with respect to y. On differentiating equation 1, which is on left hand side, we get only del z over del y. On right hand side for y x is constant for because it is partial differentiation, so differentiation constant is 0, and differentiation y is equal to 1. 0 plus 1 plus, but here this is product of two functions, so apply product rule here. So I write this function as it phi y upon x, and differentiation of x plus y. Differentiation of x is equal to 0 and y is equal to 1, so 0 plus 1 I write here, and on applying the product rule we write next term. Now this term as write as it x plus 2, and differentiate other term means phi dash which is equal to phi dash y upon x, which is because it is function of y upon x. So by chain rule we should differentiate partially y upon x with respect to y. For y x is constant, so I take out 1 upon x as a constant, and differentiation of y with respect to y equal to 1. So we are now able to find the value of del z over del y, which is equal to 1 plus 1 into this value equal to 5 y upon x, and 1 upon I multiply 1 upon x to in this bracket, we get on 1 upon x multiplied to here, x is cancel out, we get 1, and 1 upon x multiply here, we get y upon x, which is coefficient of y dash y upon x. I will use this value to find the second derivative of z with respect to y. So I differentiate again it partially with respect to differentiating again partially with respect to y, we get del 2 z over del y square. On differentiation of constant we get 0, and on differentiation of this we get y dash y upon x, but it is not a function of y, it is function of y upon x. So by chain rule we should differentiate it. For y, 1 upon x is a constant, we can consider here 1. So 1 upon x constant, differentiation of y with respect to y is equal to 1. Now we go to next term. Here we are seeing these are product of two function, so apply product rule. Differentiate first function which is consists of two terms. Differentiation of one constant is equal to 0, and differentiation of y upon x. In this, 1 upon x is a constant for y because it is partial differentiation, and differentiation of y is equal to 1. Write second function as it, y dash y upon x. Now I write this function as it, and differentiation of this function as it, and differentiation this function. So I write 1 plus y upon x as it, and differentiation of this function, because differentiation with this function becomes y double dash, which is function of y upon x. So I differentiate y upon x with respect to y partially. In this 1 upon x is a constant, and differentiation of y with respect to y is equal to 1. Now we can write it as because here two terms which are function of which is function of y dash y upon x, phi dash y upon x, and both are same, because coefficient of phi dash is 1 upon x here, and also function coefficient of phi dash y upon x is also 1 upon x. So these are like terms, so we collect these are 2 times 1 upon x phi dash y upon x, and write this value as it. What I want to multiply 1 upon x in these two terms. So multiply 1 upon x into 1 becomes 1 upon x, and multiply this to in this bracket we get y upon x square phi double dash y upon x, which is equation number, and I write equation number 5 as because I will call it these equations in for proving which we have to prove. So I start proving by taking left hand side, and after it we can take right hand side, and we will show these both sides are equal. This will we get by this we get proof. So I write here left hand side x del 2 z over del x square minus del 2 z over del y del x. Sorry. Now I will write the value of these value from equations. First of all, I write this value del 2z over del x square, which will be found in equation number 3. So I write this value from equation number 3. I write this value as it in here. So I write 2 y square upon x cube phi dash y upon x. Without any change, I write it's from equation number 3, y square upon x cube plus y cube upon x 4 and phi double dash y upon x. And after writing this value from equation number 3, we have to write this value from equation number 4. So I write this value, but here we are seeing that both two terms are negative. What this sign, but this sign is negative. So on opening the bracket of consider here is a square bracket. When opening bracket, minus sign convert this negative sign to positive. So I write here it in positive. So I write plus 2y upon x square phi dash y upon x, and next term which becomes positive from negative y upon x square plus y square upon x cube phi double dash y upon x. I close this bracket. Now on I want to collect like term so that our left hand side means x del 2z over del x square minus del 2z over del y del x becomes on multiplying the x in all the terms, we will get the coefficient of y dash upon phi dash y upon x as I write here on multiplying x here, then the power of x cube become x square, and on numerator is 2y square upon x square, and also here terms of y dash present also here, and on multiplication x here we will get x cancel out and only we get plus 2y upon x here, and this is the coefficient of phi dash y upon x. I write these two terms on multiplying x to all these two terms, and on multiplying x remaining two terms we will get the coefficient of phi double dash. So I write here the coefficient of phi double dash. So I write here on multiplying x to this we get here y square upon x square. But this term also present here because when x multiply to this term, x cancel out here, and x square we get x square here, y square upon x square. This term also become find here. So these are two terms. So I write 2 times y square upon x square here. Now we have to write these two terms. So I write this term on multiplying x to here, x cancel out, so power of here x3, and we get y cube upon x3, which is coefficient of y double dash. Also this term we have to left to write here. So I multiply x in here, x cancel to power 2, only y upon x we get here, y upon I write y upon x, which is coefficient of y phi double dash y upon x phi double dash x. I write equation to equation number 6, which is left hand side, Now we will find the value of right hand side, y del 2z over del y square minus del 2z over del x del y. First of all, you will write the value of del 2z over del x square in last equation 5, we have find the value of del 2z over del y square. So I write this value as it without any change. I write this value. So I write 2 upon x phi dash y upon x plus 1 upon x plus y upon x square phi double dash y upon x and this minus I write this value what this value before this value minus present. So value sign of this value in equation number equation number 4 is changed. So both term becomes positive by that minus sign. So I write this value. So I write this value here because I have no space here. So I write both two terms here. So I write 2y upon x square phi dash y upon s from equation number, as I already say, equation number 4 plus y upon x square plus y square upon x cube phi double dash y upon x. Now I will multiply y to all the terms which plus which connect with plus and I will collect the coefficient of phi dash first. On multiplying y here we get 2y upon here, which is coefficient of phi dash at what coefficient of y dash also here plus 2y, but on multiplying y here we get 2y square, also here x square. So we get finally coefficient of y dash, which is function of y upon x. Also we have to collect the coefficient of y double dash. So I multiply y to these two, this term and this term. What we are saying that here y upon x square is present in both term. On multiplying y it become y square upon x square, also here y square upon x square, which is coefficient y double dash. So it becomes 2 times y square upon x square. Now we have to write these two terms we have to left here. So I write first this term on multiplying y, this power y square becomes y cube. So I write here y cube upon x cube, and now I multiply this y here. So sorry, I multiply here y here, this value we get y upon x, which is coefficient of phi double dash y upon x. Here we are saying that this is left and right hand side of which we have to prove. I write it as equation number 7 from equation number 6 and 7. We are seeing that right hand side of right hand side are equal, because here 2yx 2 upon x, here also 2 upon x plus 2y square upon x square, also here 2y square upon x square. This is coefficient of y dash function of y upon x, it is also function of y dash y upon x. Also there is no different in these values of second term on the right hand side of both equation 6 and 4. So right hand side of both equation are equal, so their left hand side also equal, equation 6 and equation 7 right hand side here. So I write from equation 6 and 7 we get x del 2 z over del x square minus del 2 z over del y del x. Consider it is minus sign and it is upon sign, is equal to y del 2 z over del y square minus del 2 z over del x del y. It is not other than this value which have to we have to prove. So it is a completed question here. Thank you very much indeed for listening me. Wa akhiru dawana alhamdulillahi rabbil alamin.